Good day. I hope you are fine today. I am Ivan Rio Vanessa, and this short video is for the compliance to my subject CS6105 Discrete Mathematics. I am currently studying Bachelor of Science in Information Technology at AMA University Online Education Curriculum. I hope you'll enjoy this presentation. Let's get started. I'm given some tasks regarding with some previous topics like proposition, truth table, etc. So here are the problems. So my tasks are the activity 1, translating English sentences to a statement in propositional logic. And the second activity is proving if two sets are equal using listing method and membership table method. So, activity number 1, translating English sentences to a statement in propositional logic. This is the key instruction. Identify the atomic propositions and represent them using propositional variables. And number 2, determine appropriate logical connectives. So, um, here's the example. If there's no rain, then I will go to the mall or to the school. Example answer, let A denote if there's a rain and B denote I will go to the mall, then C denote I will go to the school. So here it is. So let's go to the sentence problem 1. It says here, if prescription antibiotics or any antibacterial medicines do not work to kill viruses, then they will also not work on COVID-19. So, in this sentence, we have two atomic propositions. So let's represent these atomic propositions using propositional variables. Let A denote prescription antibiotics work to kill viruses, and let B denote antibacterial medicines work to kill viruses. So after denoting our variables, we come up to this representation. So A is equal to prescription antibiotics work to kill viruses, and B is equal to antibacterial medicines work to kill viruses. So A or B is equals to prescription antibiotics or any antibacterial medicines work to kill COVID-19. So to continue, we need to alter this to a negation so we can come up to what is needed in the problem. The statement prescription antibiotics or any antibacterial medicines do not work on COVID-19 can be represented as a negation of the disjunction of A and B. So let's represent this statement using another propositional variable. Let's C denote prescription antibiotics or any antibacterial medicines do not work on COVID-19. Therefore, the propositional logic representation of the given sentence is negate A or B is negate C. This can be read as if prescription antibiotics or any antibacterial medicines do not work to kill viruses, then they will also not work on COVID-19. So let's go to the sentence problem number 2. It says here, COVID-19 infection may be transmitted if and only if you are in close contact to an infected person or you are not protecting yourself. So in this sentence, we have 3 atomic propositions. Number 1 is the COVID-19 infection may be transmitted. 2, you are in close contact to an infected person. And number 3, you are not protecting yourself. So let's represent these atomic propositions using propositional variables. Let A denote COVID-19 infection may be transmitted. Let B denote you are in close contact to an infected person. And let C denote you are not protecting yourself. The statement COVID-19 infection may be transmitted if and only if you are in close contact to an infected person or you are not protecting yourself can be represented as the biconditional if and only if of the disjunction of B and the negation of C. So therefore, the propositional logic representation of the given sentence is this. This can be read as COVID-19 infection may be transmitted if and only if you are in close contact to an infected person or you are not protecting yourself. So let's go to activity number 2, where we have to prove two sets are equal. So the key instructions are to prove these two sets using listing method and membership table method. So here's the given. So the universal is 1, 2, 3, 4, 5, 6, 7, 8, 9, and x is equals to 2, 4, 6, 8, y is equals to 1, 3, 6, 9, and z is equals to 2, 3, 5, 7. So we have to prove x is union to y intersect z is equals to x union to y intersect x union to z. So this is um the first what is needed, the listing method. So to prove that x union y intersects z is equals to x union y intersects x union z, we can use the listing method. This method involves listing the elements of both sets and comparing them to check if they are equal. So let's begin by finding x union y intersects z. So y intersects z refers to the intersection of sets of y and z, which means we only consider the elements that are present in both sets. So based on the given, y is equals to 1, 3, 6, 9, then z is equals to 2, 3, 5, 7. So the common element between the two sets is 3, right? Is 3. Now we find the x union y intersects z by taking the unions of set x and y intersects z. So x is equal to 2, 4, 6, 8 union the intersect of y, the other result from what we got earlier from y intersects z, which is 3. So by getting the union of the two sets, we come up to 2, 3, 4, 6, and 8. Now, let's find the x union y intersect x union z. X union y refers to the union of sets of x and y, which means we consider all the elements that are present in either set. So in this case, x union y is equals to 1, 2, 3, 4, 6, and 9. And also, for x union z refers to the union of sets x and z, which means we consider all the elements that are present in either set. In this case, we have 2, 3, 4, 6, 7, and 8. Now, we find the x union y intersect x union z by taking the intersections of the two sets. So we put the value of x union y here and the elements of x union z here. So their common elements are 2, 3, 4, 6, and 8. So after comparing the results, so here are the results we got earlier. For x union y intersects z is equals to 2, 3, 4, 6, 8. And also the elements in x union y intersect x union z is 2, 3, 4, 6, 8. Therefore, we can conclude that x union y intersects z is equals to x union y intersect x union z. Since both sets contain the same elements, we can conclude that they are. So let's proceed to the last method that is needed. So here's the membership table method. To prove that x union y intersects z is equals to x union y intersect x union z, we can use the membership table method. First, we construct a membership truth table of um, X union Y intersects A. For Y intersects A, we'll do the same with the logical and behavior, where evaluates to true if and only if both of its operands are true. So here, like, I'll just use a pen. So Y intersects A. So uh it says here that we evaluate to true if and only if both of its operands are true. So here Y and Z are the same. So 1, here 0, here 0 also, 0, 1, 0, 0, and 0. So we have now the result for Y intersects A. So we evaluate this X union Y intersects A. So for X union Y intersects A, we will treat this like an or operator. The logical disjunction or evaluates to true if at least one of its operands is true. So here, same one. We also have 1 here. So 1, X, 1, 1, 1, and then all 0. Now we have this result. So we can go to the next membership table, truth table for X union Y and intersect X union Z. So for X union Y, so 1, 1, 1, 1, 1, 1. Okay, 0. Then for X union Z, 1, 1, 1, 1, 1, 0, 1, 0. Let's check if this is correct. Okay. Then for X union Y intersect X union Z, 1, 1, this one, then 0, 0, 0. Okay. So as we see from the result earlier, they have the same, right? Okay. So the result is they have the same truth value, meaning they are equal. Therefore, we can conclude that X union Y intersect Z is equals to X union Y intersect X union Z. Wait, we have to, I think, I think that's it. Yeah. Now, now we have solved the problems that are given. I hope I have explained clearly, even if this is a short presentation. So thank you. Thanks for watching.